Hello friends, welcome to Learner's Planet. Friends, this is our first session for basic algebra. In this session, we are going to discuss about the basic algebraic identities. The questions based on algebraic identities are frequently asked in competitive examinations, right? So, let's begin this session. Basically, friends, algebra is the study of variables. The first the thing that we are going to take over here is algebraic identities. Right? The very first is x square minus y square. That's x minus y and x plus y. Right? This can be written as this and this can be written as like this. Then x plus y whole square. So that is x square plus 2xy plus y square. Then x minus y whole square is equal to x square minus 2xy plus y square. When this is plus, this is plus. When this is minus, right? Then we come to x cube minus y cube. So that is x minus y, x square plus xy plus y square. Then x cube plus y cube, that is x plus y, x square minus xy plus y square. When it is minus over here, it is minus over here and plus over here. And if it is plus over here, then it is plus over here and minus over here. Right? So this way you can memorize them. Then we have x plus y whole cube. That is x cube plus y cube plus 3xy x plus y, right? And then x minus y whole cube is x cube minus y cube minus 3xy x minus y, right? See the difference? When it is plus, everywhere it is plus. When it is minus, we have minus everywhere, right? So x cube minus y cube minus 3xy x minus y. Then we have x4 minus y4. So that is x square minus y square and x square plus y square. And this is x minus y, x plus y, then x square plus y square. Right? Now, the important thing that you have to observe over here, the questions asked on factors also, right? Now x square minus y square is having the factors as x minus y and x plus y. These both of them are factors, and x square minus y square is multiple of x minus y and x plus y both, right? So that is an important thing. Just learning the formula is not at all enough. You need to understand, right? So this x minus y and x plus y, both of them are factors of x square minus y square. That means x square minus y square is divisible by x minus y and x plus y both, right? Similarly, x plus y whole square, this is the factorization. And here if we see x cube minus y cube, this is x minus y, and this, and x cube plus y cube is x plus y into this. That means x minus y is factor of x cube minus y cube. So we can say x cube minus y cube is definitely divisible by x minus y. Similarly, x cube plus y cube is definitely divisible by x plus y. And over here, x raised to 4 minus y raised to 4, that is x square minus y square. Finally, it is converted into x minus y and x plus y. So x4 minus y4 is definitely divisible by x minus y and x plus y. I just put up one example. Say I have suppose 25 raised to 4 minus say 12 raised to 4. Right? So what will happen? So this is x raised to 4 minus y raised to 4. So x minus y and x plus y, both of them will be surely factor. That means 25 minus 12, that is 13, and 25 plus 12, that is 37. Both of them will be factor of this. So if you are asked what will be the remainder if this expression is divided by 13, then the remainder will be 0, because 25 raised to 4 minus 12 raised to 4 is divisible by 13. So if it is divisible by 13, you won't be getting remainder anything except 0. Getting my point? Similarly, this expression is divisible by 37. So if you divide this expression by 37, then the remainder will be 0. So basically, this is the application of algebraic formulae. Just do not remember the expansions of them. Okay, you need to understand the applications. Okay, getting my point? Similarly, suppose I have some other expression, say 19 cube minus say 12 cube, right? So if you divide this expression by 7, this is suppose y, if y is divided by 7, then remainder is what? Now a cube minus b cube format is there. That means a minus b or this x minus y will be factor. If it is y, I can replace it with a cube minus b cube. So a cube minus b cube is having factors as a minus b and some other is there. But definitely it is divisible by a minus b. So here a minus b, if I see 19 minus 12, so that's 7. That means it is definitely divisible by 7. Now if it is divisible by 7, the remainder will be 0 obviously. Okay, quotient will be something, but remainder will be 0. Okay, so this is precisely the application of an algebraic identity. Okay, let's take some more identities. Now till now we have discussed 2 terms. Now suppose there are 3 terms. So say a plus b plus c whole square. Maybe a plus b plus c or maybe this x plus y plus z, doesn't matter, right? Now how to write the expansion of this? Just listen to me carefully. Square of individual a square plus b square plus c square. Then 2 combination of this 2 and this 2. So 2ab plus 2bc plus 2ac. Right? Similarly, if you have to write the expansion of say a minus b plus c whole square, the first thing is a square plus b square plus c square, then combination of the 2 terms. So a into minus b, so minus 2ab, then a into c, both of them are positive, so 2ac positive, then b into c, now b is negative, so further 2bc will be negative. So this way you can write the expansion of the this algebraic this term, right? Similarly, if I have a minus b minus c whole square, then a square plus b square plus c square. Now a into minus b, so it's minus 2ab, then a into minus c, minus 2ac, then minus b minus c, so it's positive bc, right? So this way you can expand very easily. Now the next, that is very important, a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus ac minus bc. Now this looks like to be tedious, but application of this algebraic identities are very important, frequently asked in competitive examinations, right? So just learn it properly. Okay, now what is the speciality in this identity? That is, if you see this a plus b plus c, right? So if a plus b plus c is 0, then what would happen? This entire expression will be 0. That means the right hand side portion will be 0, right? That means a cube plus b cube plus c cube minus 3abc will be 0. Okay, because the entire right hand side will be 0. That means a cube plus b cube plus c cube will be 3abc, right? So suppose you are asked about any expression, any cubic expression you have to solve, then simply you can solve it like this. I put up an example. Suppose I am say 25 cube minus say 12 cube minus 13 cube. It's what? Now see this, a is 25 over here, B is minus 12 and C is minus 13. So A plus B plus C is 0, 25 minus 12 minus 13. So A plus B plus C is 0. That means A cube plus B cube. Here this plus is actually converted to minus, but the identity will remain same. We'll replace B with minus B and C with minus C. So doesn't matter, identity will remain same. So A plus B plus C is 0. That means A cube plus B cube plus C cube will be 3ABC. Here A is 25, B is minus 12 and C is minus 13. So precisely it is 3 into 25 into 12 into 13, right? So this very big expression has been converted to very small expression. Now how could the question be asked? See, suppose 25 cube minus 12 cube minus 13 cube. Which of the following is factor of this? Right? So how many factors do we have? We have lot many factors. 3 is factor, 25 is factor, 12 is factor, 13 is factor, 13 into 3, 39 is factor, right? 25 into 3, 75 is factor, 12 into 3, 36 is factor. So various factors are there, right? So suppose it is asked 25 cube minus 12 cube minus 13 cube has which of the following factor? So suppose the options are maybe 39. So yes, 39 is a factor. Suppose the option is asked 75. So 75 is also a factor. Suppose 25 into 300 is asked. That's also a factor. So this way the questions are asked. Okay. So basically it is an important identity that you should keep in your mind. I'm sure you're getting me. Now we take a generalized expression, say x raised to n minus y raised to n, right? If n is even, right? So if n is even, minimum value of n will be 2, right? So in that case, x minus y and x plus y will be factors, right? And if x raised to n minus y raised to n is there and n is odd, then only x minus y will be factor. Precisely we can describe it by x cube minus y cube. So only x minus y will be factor. Okay. Similarly, if I have x raised to n plus y raised to n, where n is even, so it won't have any factor, because if n is even, this expression will always be positive. So if the expression is always positive, it can never be 0 by putting any value of x and y, right? So n is even, no factor. Okay, that's an important thing. Xn plus yn, if n is even, no factors. That means this expression will never be equal to 0 in any case, right? We are just discussing over here the cases of real numbers. Do not go to imaginary or complex numbers. So x and y, both of them are real numbers, and if n is even, this expression will never be 0. That means this expression doesn't have any factor. Okay? Or it may have factor if we know the value of n, right? Otherwise, you cannot be sure whether x minus y or x plus y or maybe any other term will be factor of this. If you know the value of n, you can calculate the factor. Suppose, say I have 2 raised to, 4 and yeah, say 2 raised to 2 plus 3 raised to 2, right? So it's 4 plus 9. So 13 will be a factor. But that's nothing to do with 2 and 3. So that's nothing to do with x and y, right? So be very clear about it. But in case if we have n as odd number, so xn plus yn, if n is odd, then definitely x plus y will be a factor. Okay? Say x cube plus y cube, that's actually x plus y, x square minus xy plus y square, right? So x cube plus y cube, definitely x plus y is a factor. Okay? So I hope you are getting me. That means x cube plus y cube, if it is divided by x plus y, the remainder will be 0. Okay? Next is we are going to discuss some basic rule of exponents. Suppose a raised to x into a raised to y, then it will be a raised to x plus y. If a raised to x by a raised to y, then it is a raised to x minus y. This is base, this is exponent, right? If base is same and if two numbers are multiplied when base is same, then exponents are added. If one is divided by the other, then exponents are subtracted. Okay? Similarly, a raised to x raised to y is equal to a raised to xy, right? Any number having power as 0 will be equal to 1. Any number having power as 1 will be the number itself. Okay? Now friends, when we discuss exponents, we discuss surds also. Now what exactly are surds? Surds is actually irrational numbers, right? Or we can say fractional power of natural numbers. Suppose say this is fourth root of say 3 into say 2 into say 7. So this is actually a surd, an example of a surd, right? So this is fractional power of numbers. Okay, rational numbers you can say, so fractional power of rational numbers, right? Suppose 3 raised to 5 into 2, I'm sorry, 3 into 2 raised to 3 into 7 raised to say 2, and this whole raised to say 1 by 20. So this is what a surd. Okay, so these are irrational numbers and they follow the same rule as exponents. Okay, suppose if you wish to solve this, what finally you'll be getting 3 raised to 5 by 20. So 5 into 1 by 20, this one, x into y. So 5 into 1 by 20, 1 by 4, into 2 raised to 3 by 20, into 7 raised to 2 by 20, that means 1 by 10. Okay, so fractional power of number, fractional power of number, fractional power of number. So these are actually surds. When we'll be doing the problems based on surds, it will be better cleared in your mind. Okay. Now friends, our next thing in the algebra that we have to discuss is the linear equation. Right? First of all, we discuss the linear equations in one variable. Linear equation in one variable is ax plus b is equal to 0 format, right? Where a and b are constants and x is variable. Here ax plus b is equal to 0, that means ax is equal to minus b, that means x is equal to minus b by a. So the variable has this value minus b by a, right? Similarly, we have linear equation in two variables. Now friends, the important thing that I would like to mention over here, a linear equation represents a line. I just write it over here. A linear equation represents a line. Where? On the coordinate axis. Okay, I just draw a line for you. Wait for a moment. So here we are having coordinate axis. This is origin, this is x-axis, x positive, x negative, y positive, y negative. This is ox axis, this is oy axis, and this is the line, right? So any line that is, and this is origin, so line is passing through origin, right? So the, suppose I have say x is equal to y, right? So when x is 0, y is 0, that means the line will pass through origin, right? So a linear equation represents a line, and we have discussed just now a linear equation with one variable. Now I introduce a linear equation with two variables. Here in this case we have two variables, one x and other is y, right? So a linear equation, that is ax plus by plus c is equal to 0. Here a, b, c are constants and x and y are variable, right? So this is the linear equation in two variables. So that represents a line. Okay, so I just draw one or two lines. So here you can see various types of lines. The line that is passing through origin, this line that is passing through origin, this is the line that is making x-intercept and y-intercept. This is the line that is parallel to x-axis, right? So there are various types of lines, right? So if we talk about lines, precisely about two lines, right? The first one is a1x plus b1y plus c1 is equal to 0, and the second is a2x plus b2y plus c2 is equal to 0. Now these two lines, there are various situations. Okay, these two lines may intersect at one point. This is the first situation. The second situation, they do not intersect at all, or they are parallel. And the third situation is one line lies on other. Right? So we discuss each situation one by one. Now when we have two lines, this a1x plus b1y plus c1, that represents a line, and this equation also represents a line. That is linear equation in two variables. That is also linear equation in two variables. So in a plane, if we draw two lines, either they intersect at one point or they are parallel. That means they do not intersect at all in the plane. And the third thing is one line lies on the other. Right? Now see, when they are intersecting at one point, that means that is the solution of these two equations. Suppose I have a line x plus y is equal to 6 and x minus y is equal to 2, right? So if I solve these two equations, that it represents a line, it represents a line. So if I solve this two, I'll be getting x is equal to 4 and y is equal to 2, right? That means these two lines intersect at one point. Okay, because we have a common point, that is 4, 2, that is satisfied here and here, right? So this is the situation. That means the lines are intersecting at the point 4 and 2. This point is 4 and 2. That means 4 and 2 satisfied over here and here. Okay. Now I take a next set of line. Suppose x plus y, say 2x plus 2x plus 3y is equal to say 6, and here 4x plus 6y is equal to say 10. Okay, now if you start solving these two equations, you won't be getting any solution. You can very well try this. See, to solve this equation, what we'll do, we will multiply this equation by 2. So what we will be getting, 4x plus 6y is equal to 12. Now if you start solving, x will be cancelled, y will be cancelled, here 10 and 12 are there. That means you cannot get the value of x and y. That means what is happening, actually these two lines are parallel like this. Okay, so they are not going to meet anywhere in the plane. That means they are not intersecting at all. That means the lines are parallel. That means you cannot get any solution, right? So these are the parallel lines. And the third situation, I write it over here, parallel lines. And the third situation, suppose x plus y is equal to 10 and 3x plus 3y is equal to 30, right? Now if you solve these two equations, what is happening, this is x plus y is equal to 10 and this is 3x plus 3y is equal to 30. Now if you put x is equal to say 1, y will be 9, right? In case if you put x is equal to 1, y will be 9. If you put x is equal to 2, y will be 8. Here if you put x is equal to 2, y is equal to 8. So every pair of number which is satisfied here, that is also satisfied here. You can check for every value or any value of x and y. That means what is happening, the one line is lying on the other. That means all the solutions are same. That means there are many solutions, or we can say infinite solutions. Okay, so we have discussed the three situations. for the pair of lines when they are parallel, they are intersecting, and one line is lying on the other, or we have infinite solution. Now by looking at the equations of line, how could we determine that? I just come to that point. Now just listen to me carefully. I discussed about two lines, a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are the two lines, and I have discussed the three cases: intersection, parallel, and infinite solutions. Okay, so I just discussed one by one. I have shown you how the lines look alike. Now if a1 by a2 is not equal to b1 by b2, then lines are intersecting. Okay, that means you'll be getting one solution for the lines. That means this is the situation. Okay, if a1 by a2 is not equal to b1 by b2. And here a1, a2, b1, b2 are what? a1, a2 coefficient of x, b1, b2 coefficient of y, right? The second thing is that we discuss if the lines are parallel. So it's a1, if a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, then the lines are parallel. Okay, this is situation. Lines are parallel means no solution at all, right? Various words are used to represent the lines are intersecting or one solution, the lines are parallel or no solution, or the third case is when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then coinciding lines, the one line lies on the other, or infinite solutions. Right? I have already given you the examples, so you can very well verify that. So these three are important points if we talk about two lines or two linear equations. Okay, this is called as simultaneous equation or linear equation, a pair of linear equation, right? So if we have to find out the values of x and y, looking at the three conditions, in this case we can find out the single or unique value of x and y, right? In this case no solution is possible, and in this case no unique value of x and y will be there. For every x there will be a y, so you keep on putting x, you keep on getting y, right? So friends, I have discussed various concepts related to algebra in this session. We'll be discussing some more concepts. We'll be discussing even quadratic cubic equations in our next session. After that, we'll be going for problem solving. Okay, once you are clear with the basics. Okay, I'm sure you are enjoying the sessions. So let's meet in the next session once again. Bye-bye.